All right, so what I'd like to do, I'm going to start the recording here. All right, and this is what we talked about last time in our last class. We had this matrix A, and we wanted to do permuted LU factorization on the matrix A. But of course, to do that, again, the goal is we want to simulate what simulate what a computer does when it does LU factorization. So in the first column, the number 4 is the largest number in that column. So we want to use that as a pivot. Okay, but in order to do that, what we have to do is we have to take the matrix A and pre-multiply it by this matrix E1, this elementary matrix, so that the 4 is brought to the top. And then it'll be the pivot in the first column. But then, now, we look at the second column. We look at the second column, and we see that the 4 in the second column, we'll see in the second column, to get the matrix in echelon form, we're not worried about the 8. But of the 3 and the 4 in the second column, the 4 is the largest number. So we want that number brought into the second row so we can use it as a pivot to get a 0 where that 3 is. Well, in order to do that, we need to multiply by the product E1A by another elementary matrix, E2. Okay, and that elementary matrix will switch the second and third rows. So what happens is what happens is then you will get the matrix A in the form you need it to do, in the form you need. So and MATLAB will do LU factorization on this matrix. And notice in the first column, the 4 is the biggest number in that column. It'll be used as a pivot. And in the second column, we're only worried in the second column about the second and third rows. The 4 was the biggest number there. We don't worry about the 8. We're just working, getting zeros, below here in that triangle. So 4 would be the pivot we use. So the matrices E1 and E2, the row switching matrices, convert the matrix A into this matrix here, where we have 4, 8, 4 on the first row, 1, 4, 4 on the second row, and 2, 3, -1 on the third row. Okay, and MATLAB will do LU factorization on this matrix. Okay, so if you were now, what I want to do is I want to actually go into MATLAB and type the matrix A, type that matrix A in MATLAB, and then use the LU command to do the factorization. Okay, and what's going to happen is you're going to generate an L matrix, a U matrix, and a permutation matrix. This permutation matrix P. The permutation matrix P here. Maybe I'll do it in blue, so I want to make sure it's very visible. The permutation matrix P is the product of the necessary row switching matrices. Okay, so all right. That being said, let me go into MATLAB here, and you all have MATLAB available also to you. So let me actually, hold on. Let me share that one more time. There's one more thing I want to mention. Okay, so this is the third installment in our discussion. Again, the MATLAB will do LU factorization on this matrix. Okay, and all right, and the comment here is a comment that I've made, that I've talked about several times. Going to the last page, well, actually, we did talk about then how if P times A equals L times U, with our permuted LU factorization, when you take determinants of both sides and do the math, the determinant of A is going to equal -1 squared times the determinant of U. And that's easy for a computer to compute. The -1 to the second power is because you did 2 row interchanges. If you had done 10 row interchanges, you would have a 10th power there. So on page 173 in the textbook, in section 3.2, it gives a formula there that shows that the determinant of A is equal to -1 to the rth power, where r is the number of row interchanges, times the product of the pivots in U. And that's possible because the determinant of U, we're dealing with square matrices here. So U is going to be a triangular matrix, and the determinant of the matrix U would just be the product of the pivots along the diagonal. So let's do LU factorization. Let's go to MATLAB and type in this matrix A, do the LU factorization, and see what we get here. So let me just see here if there's anything else I need to mention before we move on here. Just check here if there's anything else. Yeah, there is one more thing. Yes, there is. On page 4 here, it shows the LU factorization and the resulting matrix U and the resulting matrix L. So again, if you were to do LU factorization using the section 2.5 LU factorization, you would have a different U, a different U, and a different L. A different U and a different L than what you see here. We are doing permuted LU factorization. So this is the L you would get, and this is the U you would get in MATLAB. And that would be accompanied also in MATLAB by this permutation matrix P. So on that note, let me, and we're making a recording of this, but on that note, let me go into, bring up MATLAB here. Should have it somewhere here. Here it is. Okay, so what I'm going to do, and if you have your MATLAB open, you can do it as well. I'd like you to type the matrix A. All right, so the matrix A is equal to 1, 4, 4, 2, 3, -1, and 4, 8, 4. Whoops, hold on, hold on, let me see here. Well, hey, that's what an error looks like, right? Let me see, 1, 4, 4. Oh, okay, yep, I see where the problem is. 2, 3, -1, and 4, 8, 4. See, MATLAB's nice. Now, incidentally, when you submit your work for MATLAB, I don't want you to submit work like this, where you have errors. Just give me the good stuff, right? The work without the errors. Sometimes I had a student one time submit, 10 pages of stuff with a bunch of error messages, and I had to deduct, right? That's not acceptable. I mean, you wouldn't do that in a professional report, give all your error messages, right? But, okay, you understand what I'm talking about. You're smart people, right? Okay, so let me do CLC. CLC will clear the screen. CLC command will clear the screen. Let me type A, because that's, you see here on the left how it has variables stored, all right? And I'm going to do LU of A. This is how MATLAB, now incidentally, if you ever need a little help, you can click on that command thing and you can type LU factorization, and it'll bring up, you know, LU matrix factorization. I mean, that's like your help thing. But LU of A, okay, hold on now. Oh, I'm sorry. I have to do it like this. L, comma, U, comma, P equals LU of A. That's what I have to do. And when I do that, you see, it produces the L matrix, the U matrix, and the P matrix that you saw on the previous 3 pages of the handout there. Let me just see here. So check. Hold on. Let me just check here for myself. It should be good. Yeah. So going to the going back to the handout here. Going back to the handout. Yep, that's the P matrix that MATLAB produces. And then, so this is in the recording. Here's the U matrix that MATLAB produces. And then here's the L matrix that MATLAB produces. So, you know, LU factorization is not unique. Like I said, this permuted LU factorization gives you matrices L and U. That's different than if you were to work it out by hand, like, you know, in section 2.5. Section 2.5 in the book, their LU factorization doesn't involve any row interchanges. This permuted LU factorization does. Now let me just see. There was a question here. Yeah, so it's all in the recording here. Are there does anybody need me to go back to MATLAB? I just do the brace with the LUP. You know, I just do, let me go back to MATLAB, so it's all in the recording here. And I will obviously, I'll post this recording in where in Blackboard, where the MATLAB assignments are. Hold on. Yeah, so let me do a CLC, and then I'll bring that. There we go. Okay. So are there any questions at all regarding this guidance I'm giving you to help you appreciate and understand MATLAB assignment 2? You know, Matthew, just ignore what I did before, the LU of A. Ignore that. To be honest, I had just forgotten to put my that in. See, I wanted to show the matrices L, U, and P. Okay, and so to do that, I need to have in the brackets L, comma, U, comma, P, or equals LU of A. I mean, that I'm not worried about anything else. If I just type LU of A and MATLAB gives me something, I'm not interested in that. What I'm interested is what you see here. Okay, you know, I mean, the MATLAB is the output is supporting what you're seeing in that handout, and the reason I made that 4-page handout is so you can understand what MATLAB's doing. Okay, is that helpful? How many find this helpful? Does this help? You appreciate permuted LU factorization? Excellent. Thank you, Sega. Thank you, Devahar. Thank you, Solomon. I appreciate it. Thank you, Kevin. And very good. Very good. Okay. Thank you, Matthew. A lot of thumbs up on that. Thank you, Matt. Thank you, Hugh. Appreciate it. Appreciate it, everybody. Let me stop the recording.